Assalamualaikum warahmatullahi wabarakatuh. So for today we are going to present to you guys a topic which is about gas chromatography and also high performance liquid chromatography. So I will be explain first for the introduction part for the experiment 5 first. So what is gas chromatography? Gas chromatography is a technique to separate components based on their differences of boiling point. And there's a two type of gas chromatography, which is first we have a gas solid chromatography and also gas liquid chromatography. And as for the principle, when a sample is injected at the column, each component is transported towards the detector by the carrier gas, which is we call as mobile phase. Gas chromatography also have many types of detector, such as we have flame ionization detector, thermal conductivity detector, flame photometric detector, electron capture detector, and also we have mass spectrometer. But for this experiment, we use flame ionization detector, or we call as FID.
Okay, so for the methodology, firstly, we are going to talk about the first part, which is sample handling. For the sample handling, the syringe was rinsed before filling it with sample. The volume of the sample may be more than the required volume. The syringe was ensured there is no air bubbles in the syringe. If there is air bubbles in the syringe, you must tap gently to remove the air bubbles. And the syringe was held vertically, needle up, with the plunger was pushed to the required volume at eye level. The excess sample was removed using a tissue. Since the samples are volatile, the preparation and injection of samples are done quickly as possible. Okay, for the second part is the B part, experimental part. Okay, this is mostly we talk about using the instrument. Firstly, we must set the initial for the oven temperature, which is 70 degrees for the final injection temperature, 180 degrees, the temperature is 180 degrees. And after that, we must compare the retention time of each component. And then at last, the column temperature was needed to be changed. Okay, so this is the last part, which is the C part, operation of the GC. This is the part where the each sample was tested. This is the combination where the sample and the instrument was tested long together. So the sample was injected into the liner, and then we need to change the concentration. If the sample is in high concentration, choose speed mode, and if the sample...
I am Nur Shuhada binti Abdul Hadi. I am going to explain on the result. This is the table of retention times of standard and unknown sample. From this table, we could interpret that the standard mixture has the retention times of 1.47 minute and 1.79 minute at 70 degrees Celsius. At 70 degrees Celsius, the 2-propanol has the retention times of 1.47 minute, meanwhile the N-butanol has the retention times of 1.80. The unknown sample has the retention times of 1.47 minute at 70 degrees Celsius. At 100 degrees Celsius, the standard mixture has the retention times of 1.39 minute and 1.52 minute. However, at 140 degrees Celsius, the standard mixture has the retention times of 1.33 minute and 1.39 minute. From this result, the unknown sample can be easily determined based on the retention times, which is 2-propanol.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shami and I'm going to present to you about the brief discussion for this experiment. The result of the experiment suggested that the retention time of N-butanol is 1.47, meanwhile the 2-propanol retention time is 1.79 at 70 degrees Celsius respectively. Based on the retention time we get from the experiment, we determine that the standard mixture consists of 2-propanol and N-butanol as it had a more similar retention time in comparison at 70 degrees Celsius. We also determined that the unknown sample are 2-propanol as the retention time at 70 degrees Celsius is almost the same as the 2-propanol. Temperature affect both retention time and resolution. As the temperature increase, the peak retention will be shortened. The same case can be said about the resolution, because just like the retention time, when the temperature increase, the resolution is shortened. For the errors, it is determined that there may be several errors that may affect the retention time at the end of the experiment, such as change in flow rate of carrier gas, leakage in carrier flow path, damage at stationary phase, and the time between injections.
I would like to conclude this presentation by stating that the objectives of gas chromatography has been answered. It was determined that the retention times of N-butanol is 1.80 minutes while the 2-propanol is 1.47 minutes. Based on the retention times, the components present in standard mixture is N-butanol and 2-propanol. The unknown compound is determined to be 2-propanol since the component has the same retention times as the 2-propanol, which is 1.47 minutes. A high column temperature will give shorter retention times as more components stay in the gas phase and will result in the resolution to worsen.
So I will explain for the introduction part for experiment 6, which is high performance liquid chromatography. So, what is high performance liquid chromatography? Basically, it's a technique to separate the component of mixture, utilize a liquid mobile phase, and also for the principle, when the solute is injected onto the top of column where separation occurs, each component elute from column to detector, and response of detector to each component is displayed, and we call it as chromatogram. And we also have two types of HPLC, which is we have normal phase and we have a reverse phase. But for this experiment, we use the reverse phase. And this is because it can be used for the polar, non-polar, ionizable, and ionic sample. And the instrument used in this experiment is HPLC UV detector and also HPLC PDA detector.
Okay, so for the methodology, there are two parts for the methodology. First part is the A part, the experimental part. Firstly, we need to prepare caffeine standard solution. Firstly, is standard solution 1.0 milligram of a milliliter of solution A as the solution A. And then second solution is working solution 0.1 milligram of a milliliter as the solution B. And then for the second part, we need to prepare the sample by using soft drink, 10 milliliter of soft drink, a magnetic stirrer to remove any carbocation, and 2 to 5 aliquot filter, filtered through a membrane filter to remove any particulate matter. Solution B was injected into the HPLC to establish retention time of caffeine. The peak area of the caffeine was measured. Then, the soft drink was injected into the HPLC instrument, and then the peak area corresponding to caffeine measured by referring to its retention time. And then, for the B part, which is operation of the HPLC. Okay, firstly, starting the instrument. The instrument need to be switched on, but the first need to be turned on first. Then the on button switch according to the level hardware number. And then we need to run the software as Okay, so then continue to set up, such as the oven temperature. There are also for the power on event. But there is part, some part that we did no need to change on anything, such as the status start menu at the program menu.
This is the table of retention times and peak area of caffeine in the standard and sample. From this table, we could interpret that the caffeine standard has the retention times of 0.908 minutes and the peak area of 1,479,720 microvolt per second. The retention times for the first run of the soft drink sample is 0.903 minutes, while the peak area of caffeine is 2,082,175 microvolt per second. The retention times for the second run of the soft drink sample is 0.906 minutes, while the peak area of caffeine is 2,237,029 microvolt per second. The retention times for the third run of the soft drink sample is 0.873 minutes, while the peak area of caffeine is 2,164,372 microvolt per second.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Sharmi, and let's continue with the brief discussion for the experiment seeds. It is determined that retention time of a caffeine in standard solution is 0.908 minutes. The mobile phase between in this experiment have a ratio of 70 to 30 for acetonitrile and deionized water. It should be able to dissolve the analytes up to the concentration suitable for the detection. For the partition chromatography, is reverse phase used in this experiment, as the alkene C18 stationary phase is non-polar while the mobile phase is polar. Let's continue with the detector used in this experiment. The detector used in this experiment is UV detector, known as photodiode array detector. This detector operates by absorbing the electromagnetic radiation, so it is suitable for the organic chromophore. The amount of caffeine in the soft drink were managed to determine using the response factor formula, which is response factor of the caffeine standard equal to peak area of caffeine standard divided by concentration of caffeine standard. And then from that, we can use peak area of caffeine standard in unknown sample divided by the response factor we get earlier to gain the amount of caffeine in the unknown sample. So using the formula, we managed to determine that the amount of caffeine in the soft drink is 140.71 ppm. So for the error, we determined that the result may have been interrupted by the lab temperature.
In conclusion, the objectives of the high-performance liquid chromatography have been answered. The retention time of a caffeine in standard solution was determined to be 0.908 minutes. There are 3 runs for the soft drink sample in this experiment. The peak area of caffeine for the first run is 2,082,175 microvolt per second, while for the second run is 2,237,029 microvolt per second. For the last run, the peak area of the caffeine is 2,164,372 microvolt per second. The amount of caffeine in the soft drink was determined to be 140.71 parts per million. Thank you.